Good morning, boys and girls. As you can see, we're going to do some math today. This lesson is for Monday, April 27th, and it's math lesson 147. It's a review lesson of many things that we've learned all through the year. And from this point on, we will be having more of these review lessons. Sometimes a little bit of something is put into the lesson that is new, but really not anything that will be difficult for you. So for the most part, these will be review lessons, right? So we're going to start with this. And it says 3 1/4, and that's how we write it when we see it on a piece of paper or sometimes on a test. We have only been doing the fraction by itself, but now we're going to do the whole number with the fraction. When you get in third and fourth grade, you will call it a mixed number. Why is it mixed? Because we have a whole number that we've been using since kindergarten, and now we're going to be using the fraction. So a whole number and a fraction together is called a mixed fraction, a mixed number. All right, so here are the whole numbers, and here's the fraction. This is 1/4, isn't it? 3 are missing, and 1 is still there. If all the parts were there, we would say 4/4 if we said it in a fraction. 4/4 is the same as one whole number. So 3 1/4 is what we're seeing here right now. Okay, now let's look at another one. Let's go to, that is not divided into fours. And if you look carefully, you can see where this one separates. So we have 1, 2, 3. We have 3 parts. So these are divided into not fourths, but thirds. So it would be 1/3, 1/3, and 1/3. But how many parts are shaded? 2. That means that 1 part is missing. 2 parts are still there. So we would write it like this. Remember, this is a mixed number. Here's all the ones that are whole numbers. 1, 2, 3. So 3. And how many parts of the fraction are still there? 2. So we would write a 2 over the top and 3 at the bottom. It's called 2/3. Addition and subtraction have names like add-in, sum. Subtraction have names, minuend, subtrahend, difference. Multiplication has factor, product. We haven't learned all of the division. We've learned the quotient, which is the answer. The number inside of the division box is called a dividend. And the number outside the box that we divide by is called the divisor. Well, in fractions, the top number has a name and the bottom number has a name. Let me do this. The top number is called the numerator. The bottom number is called the denominator. Did you know these are my initials? They're my initials. This is my first name. This is my last name. So, numerator is the 2. Denominator is the 3. If you forget this, it's okay. But you will be taught this again. So some of you remember that will be a good thing for you. All right, now we have looked at these, and in your book, in this lesson, you are going to have to choose the right one in your exercise. There are little bubbles, you know, and you mark in the bubble of the bubble with the right answer. So you should do pretty well on that. Okay, now we're going to move on to Roman numerals. Just a little bit. Sorry, excuse my throat, please. And X is 10. Ooh, here's a B, I. Now wait, do we add to the 5, 3, or do we subtract? If the small is on this side of the larger, we add. If they were on this side of the larger, we would subtract. So what you do is remember what a B is. It's a 5. And you know what these are. The I's are 1s. So you add 5 plus the 3, and what is your answer? 8. Good. We already decided a V is a 5. This one's pretty easy. 2, good. Now, here's an X, is a 10. The I is on this side, not this side. So subtract. X minus 1 equals 9. Okay, now you see the B and the I is on this side. Do you add or subtract? Correct, add, and the answer is 6. Oh, now the I is over on this side. If the I comes first, subtract. So 5 minus 1, 4. Oh, okay, that would be 1. And this one is the largest one of all. Do you remember when I was talking about when Jesus comes back and he has his kingdom, he's going to rule for 1,000 years? And that's called a millennium. Well, a millennium is 1,000 years. So I wonder what this M, what number it stands for. 1,000. I think the millennium got its number from, or its name from, a Roman numeral. The M stands for 1,000. Are you going to add or subtract? Yes. 7. An L. Now I always got the L and the D mixed up. For some reason, I had trouble with that. So one day I decided that a little 50 was sitting there on the L, like it was a chair, and it's sitting on the chair. 50 is sitting on the chair. Then I remembered that L stood for 50. Little games, little tricks like that, little stories you can make up will help you remember things that you may be confused about, or you're just having a hard time remembering. So remember that the L has a 50 sitting on the chair. 50. 50. Now here's the D. This is the one I would get mixed up with too. Well, if the L is 50, then I would know that the D was the other 5, 500. So D is 500. A C. A century is 100 years, and a C in Roman numerals, you're right, is 100. Now we're going to go through these very quickly. See how well you do. 3, 10, 8, right, 5, 2, 9, 6, you're right, 4, 1, 1,000, good, 7, you added, what's sitting on the L? You're right, a 50, good for you. And then the D then would be the other 5, 500, good job. And C is 100. You did a good job on that. Okay, now I'm going to give you a quick drill and see if you can get these. XX, 20. We're going to add or subtract. Did you add? Did you get that number? Good job. X, V, I. X, 10, V, 5, and 2 more. 17. X and V are 15. 15 plus 3 more. 18. Good. Now let's do it. Oh, here's one more. This is an interesting one. Wait a minute. This I comes after the X, but with this one, it comes before the X. So which one does this I go with? It goes with this one. Okay? So we have to have a go with this one. This one stands alone. So when you have a situation like this, remember the small one that's in the middle will always go with the one over here. And this one stands alone. So this is 10. And so that would be X minus 1, 9. 10 and 9 are 19. Okay, look at that again. 19. Okay, what is this one? 20. What is this one? 16. What is this one? 17. And this one? 18. And so this one is 19. Good job. All right, let's look at the next thing that we need to do. One of the things that I noticed were clocks that sometimes didn't have the right answer. And I came in the middle of the year, so I didn't know how much you had learned and how much you hadn't learned. Well, we found this old clock in an old workshop, and they were going to throw it away. And we said, hey, you know what? These work. What time is it? It's 12 o'clock. Not really. And we thought we should save it and use it to teach with. So here it is. This is a really old clock. They took it all apart. I think whoever it was going to try to put it back together and make it work again. That's my guess. We need to write a story about this clock. What happened? What was the history of this old clock? Well, right now we need to do clocks. In your book, it says write the time for the first one. So we had to do this. 1:30, 2 o'clock, 2:30, 3 o'clock, 4:30, 5 o'clock, 5 o'clock. So when we count by 5, all the way around, we come up to 60. Can you see that 60 right there? How many minutes on a clock? 60. For 1 hour, good. So it's 4 o'clock, okay? See that? And we keep going around, and every time the long hand goes around, the little hand goes from one number to the next. Watch. You see that? Oh, I did it backwards. I need to watch the clock, not the screen. So that's 5, and that's 6, and that's 6:30. But this hand is moved. And this is 7 o'clock. And this is 7:30. Looks like someone might get confused and think it's 8:30. Why? Because it's so close to the 8. But if it isn't exactly on the 8, it's not 8:30. It's not even 8 o'clock. So we move it. And now it's 8 o'clock. And now it's 8:30. And now it's 9 o'clock. And now it's 9:30. Even though it's really, really close to that 10, it's not there yet. Move it right about there. So let's start at 10 o'clock, okay? 10 o'clock. How many minutes in an hour? 60. How many minutes between numbers? 5. So does that mean if I count by 5s all the way around the clock, I'll get to 60? Well, let's try. I'm going the wrong way. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. Hey, it does end up 60 minutes, 1 hour. Now, what you need to do is to find the first clock. What time does it say? Does it say 10:25 or 9:25? Let's go back. Here's 9 o'clock. Now we're going to go 25 minutes, 5, 10, 15, 20, 25. So we're going to move the minute hand, which is the longest hand, because it takes the longest way to go. And we move it here. What do we have here? Is it on the 9? No, but is it on the 10? No. What's our reasoning? If it isn't on the 10, it isn't 10, it's 9. So 9:25 would be what? The first time. It says in 1 hour later, so if it's 9:25 here, 1 hour later would be all the way around and stop at the 5. So let's do that and see what happens. It's 10 o'clock, isn't it? But we have to go here, 10:25. So we stop, and this is what it looks like. It's halfway between the 11 and the 10. Is it to the 11 yet? No, so it's not 11:25. It's this one, 10:25. Sometimes on a test, when you really can't tell, you begin to think it's the next number. Now just watch this for a minute. Let's just move on up. What's happening? It's almost on the 11, but it's not exactly on the 11, so we have to move it, and then it is. So until, let's go to 45 minutes. It's almost on this 11, isn't it? And so you might think it's 11:45, but it's still 10:45 because it's not exactly on the 11. And sometimes we struggle with that. We think because it's closer to the 11, it must be that time. But until it's exactly on the 11, we have to do the 10. This is what 10:25 looks like, okay? It's not at the 11, it's not on the 10. We don't use the 11, we have to use the 10, the number that's first. 10 is before 11. All right, now it says go to 1 1/2 hour later. Ooh, so this is 10:25, and we have to go 1 hour and then another half hour. So let's go 1 hour. We're going to go all the way around back to the 5. All right. Now it's 11:25 and almost 12. But we have to go another 30 minutes because 30 minutes is half of 60. And we need to move it, counting by 5s. 5, 10, 15, 20, 25. Whoops, I counted that wrong. It would be right here. That's right. 5, 10, 15, 20, 25, 30. A half an hour. And this is what time it should be. Does it look like it should be 12? Ugh. But well, this one might be a little off. It's not supposed to be exactly on the 12. Okay, it ought to look like that. And so it would still be 11 what? 11, well, all the way around the clock to 11 is 55 minutes, I think. Let's count. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. So it would be 11 and 55 minutes because it's not 12 o'clock yet. Well, I hope this helped you some. We may have to teach this again. Sometimes we need to hear it more than one time. As long as I can keep borrowing this clock, we'll be good. I'm going to lay it down over here. And we need to look at some flashcards. 1 week, 7 days, right? I have the side showing. 1 year, 12 months. Aha, 1 minute, 60 seconds. 1 hour, 60 minutes. This is the one we had to remember today in order to do the clocks. 1 day is 24 hours. Remember 12 and 12? We talked about that. 12 hours would be approximately the daylight, and then 12 hours again would be the nighttime, and we call that 1 day. So 12 plus 12 is 24. 24 hours in 1 day. 1 year, about 52 weeks. And why did we say that? Well, because we have some months that are 30 days, and we have other months that are 31 days. And there's 1 month, February, right, has 28. This past year, February had 29. That happens every 4 years. So we keep our calendar in balance. 1 year, 365 days. 1 leap year, that's when February has 29 days instead of 28, 366 days. Okay, now let's turn it around and see if we can do it. 7, 12 months, 60 seconds, 60 minutes, 24 hours, about 52, 365, 366. And back to 7 days in a week. Okay, really good. I'm gonna wrap these up in the rubber band. We'll move on to the next thing. In your book, there are some burros. Those are like little donkeys. And we have been talking about national parks in our country, and this one talks about the Grand Canyon. The Grand Canyon has a river running through it called the Colorado River. and it's a beautiful sight to see. I was able to go there once, and pictures say a lot, but when you're standing on the lookout area and you're looking across this vast area, realizing how huge and beautiful it is and how far down it is into the canyon, it's just awesome. And you think, I thought of God and his creation. Well, there are people who will take you for a ride on the Burros down into the bottom of the canyon. And it's kind of, I didn't do that, but some people did, and they really enjoyed it. So that's why we have Burros on our math page today. And it wants us to do a fraction. So it says, color 1/4 of the Burros brown. Well, first of all, you have to know how many Burros there are. There are 8. And you have to divide them into how many groups? If you're going to get 1/4 and 1/4 and 1/4, how many 1/4s can you get? So you divide them up into groups. Well, I don't have any Burros right now, but I have some sticks, and I'm going to pull them out. And I'm going to try to have as many sticks as there are Burros. Do you want to count your Burros and see how many there are? 1, 2, 3, 4, 5, 6, 7. There's 8 Burros, so I have 8 sticks. Okay? These will represent one, 2, 3, 4, 5, 6, 7, 8. Now, we want 4 groups, and we need to divide them equally. So let's try. So if I divide them this way, there's only 2 groups. If I divide them into 3, then they're not equal. So what's left? I did 4 and 3. We need to try 2, don't we? Okay, 2 and 2 and 2 and 2. We equally divided it into 4 groups. 1, 2, 3, 4. How many Burros would be in each group then? How many would you color? That's right. Okay, remember 1/4, 2/4, 3/4, 4/4. 4/4 equals the whole group of Burros. Great. Now, what about counting by 3s? Why I am doing this is to show you something new. And I need a marker, which, here we go. We're going to count by 3s. Now, I know this chart says counting by 2s, but we can also count by 3s down here. These are the 2, 4, 6, 8, 10 that we've done before. Now we're going to switch it around, and I'm going to draw a circle around every time, a number, every time we get to counting by 3s. All right? So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Oops, do you see that? I'll have to move it closer in a minute. 21, 22, 21, 22, 23, 24, 27, 30. We just counted by 3s. Now let's leave the other numbers out and count by only the circled numbers. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Now that sounds rather strange because we're used to going 2, 4, 6, 8, right? 10, 12, 14, 16, 18, 20. Count by twos. When you count by threes, you're saying the answers to a multiplication group. If we count by threes, what multiplication group are we multiplying by? 3. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4, 12. 3 times 5, 15. 3 times 6, 18. 3 times, 7, 21. 3 times 8, 24. 3 times 9, 27. And we know 3 times 10 equals 30 because we know our tens. I hope we know our tens. We know our twos, do you? We know our fives. We know our tens. And now, if we learn these numbers, counting by threes, we will be on our way to knowing our 3 multiplication tables. So let's do this again. I'll say 3 times 1, and you say 3. Okay, here we go. 3 times 1, 3 times 2, 3 times 3, say the number. 3 times 4, 3 times 5, 3 times 6, 3 times 7, 3 times 8, 3 times 9, 3 times 10. Let's do it again. My hands are full. You'll have to keep your eyes in the right place. We'll start with 3. Look at the 3 down here. Here we go. 3 times 1. Say the answer. Good. 3 times 2. 6. 3 times 3. 9. 3 times 4. 12. 3 times 5. 15. 3 times 6. Say it. Good. 3 times 7. Over here. 3 times 8. 3 times 9. And 3 times 10. You've just said your threes. Now, what you have to do is work on these so you can say them like you say your twos, counting by twos. 2, 4, 6, 8. I'm going to try to do 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. And then you'll have learned another set of multiplication. So when you go to 3rd grade, you'll know 2s, 3s, 5s, and 10s already. Wow, I hope your teacher will be impressed with that. But it requires what? Work and determination, and not giving up, and not being lazy. Okay, so make your parents proud. Study these numbers, learn your threes, and then put them with the collection of the other multiplication tables that you know. All right, now we're going to look at the chart. Right here. I only went to the tens. Oh, sorry about that. Let's write this one in. 3 and 10. The rest okay? Here we go. All right, let's do it. 3 times 0, 0. 3 times 1, 3. 3 times 2, 6. 3 times 3, 9. 3 times 4, 20, 12. 3 times 5, 15. 3 times 6, 18. 3 times 7, 21. 3 times 8, 24. 3 times 9, 27. 3 times 10, 30. Anytime you have a 0, the answer is, say it, 0 in multiplication. Now, let's see if there's some of them you already know. Do you know this one? Yes. Do you know this one? Yes. You learned that when you learned your 2's. Do you know this one? Yes. And do you know this one? Yes. So you already know almost half of them. Let's see what you don't know. Maybe you don't know 1, 2, 3, 4, 5, 6. You don't know only 6 of them. So does that make you feel better? Now you only have to learn how many? Just 6. How hard will that be? Easy for you. I know you can do it. So practice at home. Right? Maybe your parents can write these out for you. Or you can watch this video again and practice and learn your 3's. That would be so great. And I would be so proud of you. Do you remember this ruler we had in class? It's so big, it won't fit on the screen here. On this side, we had the metric. So this is a meter stick, pretty long. And the yardstick, which we've had, only goes to 36. And so I would have to take my hand and cover that part up so that this would be the only part showing. Now, since it's so large, we're going to look at it in sections. Here's a ruler. A ruler is 12 inches, but it's also 1 foot, right? Well, let me ask you if you remember how many feet are in a yard. Who thinks they remember that one? Did you say 3 feet equal 1 yard? Yes, you're right. So let's take this ruler, 12 inches, also 1 foot, and we put it here. That's the 12, and then we go here from the 12 to the 24, and then we go from the 24 to the 36. How many feet? 1, 2, 3. 3 feet equal 1 yard. Get the whole thing in. There we go. 36 inches. See it? Okay. By the way, 36 inches equals 1 yard. Now, my question is this. What if we times them by 3? Look in your book. It's on the second page. Do you see it? Okay, is there multiplication for 3's there? Yeah. Did I do the 11 times 3? If 10 times 3 is 30, then 11 times 3 would be 3 more. What's 3 more of 30? 33. So just remember, 3 more. What about 12 times 3? It's 36. Wait a minute, didn't we just do a yard and it was 36? That's right. And we did 1, and we did 1, and we did 1. That means that there was 12 here, 12 here, and 12 here to get to the 36. So there's 3 feet, and there's 3 12s. So 3 times 12 equals the same as a yardstick. Look at that, 36. What a coincidence. Not really. Okay, now if we keep adding, we will end up with big numbers for sure. So let's look at this. 1 yard equals 3 feet. 3 feet equals 1 yard. Correct? We just measured it when we took the ruler, when we had 3 rulers go across to the end of the yard. So 3 feet equal 1 yard. Oh, that's too big. Let's do an easier one. There we go. How about this one? 9 feet equals 3 yards. That means 3 yardsticks. Well, how did we get that? We went 3 times 3 equals 9. Look on here. Do you see 3 times 3? What does it equal? 9. So what we're doing is we're taking 3 yards and figuring out how many feet. We're taking how many feet and figuring out how many yards. So let's just do it this way, shall we? 3 times 3, 9 feet. We're going to add 3 to all of these. Okay, let's try another one. And then I'll do this one. Ooh, 10 and 30. So what did we use to get this 30? We said 10, and we're multiplying by the 3. The 3 what? The 3 feet. Okay, so 10 times 3 then is 30. And if we had 6 yards and we multiplied by the 3 feet, we would get 18, because 6 times 3 equals 18. And 9 yards times 3 would equal 27. Look here. Do you see the 27? Where is it? Right there. 3 times 9 is 27. So 9 times 3 feet equals 27. Same thing. Good. Well, that was a little tricky, but I think if you listen carefully, maybe the next time, if you're still not sure about what we just did, here's what you need to understand. All of this is around our 3s and learning them. And a yardstick and a ruler just happen to be connected because 1 foot, 2 feet, and 3 equal a whole yard. And that's what we just did by adding 3 feet, or by multiplying by 3 feet. We got a new answer. We multiplied it. Okay, look at number 3 on the last page. It's a story problem. And I wrote some things out here to help us. And this is what you need to do when you're doing a story problem. This morning, there were some tents set up at the campground. Now we're still in the national park. In the afternoon, 17 more tents were set up. Now there are 47 tents set up. How many tents were at the campground in the morning? Now that is a lot to remember. And our brains really don't need to do all the work. We need to write some things down. Do we know how many tents there were in the morning? No, it doesn't tell us. It just says in the morning there were some tents set up. But it does tell us how many in the afternoon. So we need to pay attention to that. In the afternoon, 17 more tents were set up. That means that we don't know how many in the morning, but there was enough, and then 17 were added to that. But we don't know what number that is to add it to. Now it tells us there are 47 tents that were all set up. So that means 17 is part of the 47 tenths, and also the tenths in the morning are part of the 47 tenths that were finally put up at the end of the day, or at least in the late afternoon, or after the afternoon. How many tenths were at the campground in the morning? It's a missing number, isn't it? We know 17 and we know 47. Well, let's look up here. Here's what we know and here's what we don't know. Can you see it? Is that a little better? We know that there were 17 more tenths put up in the afternoon. Okay. We know there was a total of 47 tenths. So I wrote total there. Is that correct? Yes. So I took my 17 and my 47 and I made a math problem out of it. I knew this part, but I didn't know this part. Well, I knew the total because they told us. So I put a box where the missing number was that I added. Well, what's a better way to do this? Take these two numbers and do the opposite of adding, which is subtracting. So I took the 47, the larger number has to go at the top when you subtract, right? And then I took the 17, which was the smaller number, and I made a math problem subtracting. Because I thought if I subtract these numbers, I'll find the missing number. And so I did. 7 minus 7 is 30. 4 minus 1 is 30. Now I wanted to check, would 30 fit in that box? Let's try. Okay, I'm getting it. There we go. Let's put 30 here. You see that 30? It's not very dark. There's the 30. Add 0 plus 7 equals 7. 3 plus 1 equals 4. Did I find the right number? I did. Because why? They match. When you're doing a story problem, don't expect to get your answer right away or think it's really quick and easy and you can just do it. What you have to do is think about each thing that you've been told and then think about what you haven't been told. Now, I had to do this in my head first before I realized I really should be doing this. Well, was that okay for me to do that? Of course it was, because it led me to the right answer, didn't it? 30. I wrote down words, 17 more tenths in the afternoon, so I could see what I was thinking. And then it said 47 tenths in all, or all together, or total. And that all means add. So that's what led me to think, let's do this and see what happens. And it led me to the proper way to do it. And then the morning tense was a mystery to me, so I put a cloud around it. It was kind of cloudy. I didn't know the answer to that part. I didn't know about the morning tense. I had no number. I knew the afternoon and I knew the total. I went here and then I did that. And then I went back and checked it to see if they both matched. And I was right. Now you may not have to do all of this. Sometimes you can see this one in your head before you see what I saw. Okay. What do you need to remember when you're doing a story problem? You need to write some things down. Good. What else do you need to do? You need to experiment. You need to ask yourself questions. And then you need to try. This way, I did it. I realized, well, that makes sense then. So I must have done it right. So in a way, it was good I did it this way first, because then it could match with the other one. Not all story problems are the same, and not all story problems are done the same way as this. Each one has its own uniqueness, but I want to stress this. You need to think. You need to ask questions. And I think you need to also write it down. Now, it might be an easy one. You don't have to write it down, but just the same, don't forget these ideas. And it will help you get to the right answer. And that's what we need to do. Is that correct? All right. Well, that ends our lesson. I know it was long, but it was a good review. And I hope there's something in this review that refreshed your memory and is helping you to be a good mathematician. Try to learn your 3 times tables. It will be a blessing in the end. I'm going to say goodbye now, and I hope to see you soon.